Unit 5 review. Find the function graph's end behavior. So a graph, you don't need to draw this, but here's what it looks like. Yet this is x positive infinity, and this is x negative infinity. Okay, what does a graph do? We know it's a roller coaster. Y equals negative 2x to the 6th power plus 5x to the 5th power minus 3x to the 3rd power plus 6. Now as x goes to positive infinity, what does the function do? What's the y do? Well, it depends on what the leading coefficient is. It's a negative 2, so that means in this direction the graph goes down, the roller coaster goes down, negative infinity. Now, on the other side, we have to identify the degree. It's 6. Now, it's even, but that doesn't mean it's positive or negative, okay? That just means that the end behaviors have to match. So we keep it at negative infinity on this side. So it'd be like a graph going like that, kind of. Okay, now y equals 2x to the 5th power plus 3x to the 3rd power plus 2x to the 2nd power minus 4x plus 6. At least I think that's a 6. Doesn't really matter for what we're doing. Okay, now the leading coefficient's 2. It's positive, so the graph goes to positive infinity this way. Now the degree is 5, and that's even. That's odd. So we need to switch that on the other side to negative infinity. I have to have opposite end behaviors. Okay, in the next problem, write a polynomial function given each of the roots. Only real rational values need to appear in your answer. Remember, i's and radicals come in pairs. There's no i's, there's no radicals. So we just line it up. X minus, but then it goes to plus 3. X minus 4 and x minus 12. It's like you're doing the opposite of solving. They give you the solutions, you write the equation. Because if I had to solve it, I'd put x plus 3 equal to 0. It ends up at negative 3. Okay, number 4, we have radical 5, so we know that radicals come in pairs. Negative radical 5. I's come in pairs, negative 7i, and negative 3i. So x minus, that'll go plus radical 5, and then x minus the square root of 5. X minus, that's going to go plus 7i, and x minus 7i. And then x plus 3i. X minus 3i. Now you got a whole lot of cleaning up to do. We need that multiplied, and that multiplied. So in the end, we're going to end up with 3 factors. Okay, so x times, remember, it's FOIL, but you skip the middle two, because the middle two products, because they just cancel. So x times x, and then square root of 5 times negative square root of 5. So x times x is x to the 2nd power. Now a positive times a negative is a negative, okay? And then negative's outside the square root, but then the 5 times 5 is 25. So then the square root of 25 takes me to a 5. Now it's negative 5, so that's x to the 2nd minus 5. Okay, now x times x. Then 7i times negative 7i. It's negative 49i to the 2nd. I to the 2nd is equal to negative 1, so it's negative 49 times negative 1, which is positive 49. So since it's positive 49, it's x to the 2nd power plus 49. And then here, x times x, and then 3i times negative 3i. So x to the 2nd, and then negative 9i to the 2nd. But remember, negative 9 needs to be multiplied by negative 1 now, so that equals 9. It's positive 9, so it's x squared plus 9. There's your function. Okay, number 5, negative 3, no I, no radical. 4i is an I, so negative 4i. radical 6 would be negative radical 6. So I start with 5 factors, x minus and then plus 3, x plus 4i, x minus 4i, x minus and then plus square root of 6, x minus square root of 6. Okay, now the x plus 3, that's just dropped. Then the i's and the radicals need to be simplified. Okay, that'll form into 1, that'll form into 1. So x times x, and then 4i times negative 4i. So it's x to the second, negative 16i to the second, but then that's negative 16 times negative 1, which is 16. So it's x squared and positive 16, so it'd be x squared plus 16. Then x times x, and then square root of 6 times negative square root of 6. X second, positive times negative is a negative, and then the square root of 36, and that turns into 6. So x second minus 6. Yes, the i's always turn into a plus. The radicals will be a minus. Okay, find all roots of the equation by factoring. And these are our factoring procedures, GCF DOPS, GCFT, and all that. Okay, how many roots do we have? We'd have 3 roots. Now, we have an x to the 3rd power degree, followed by an x second, and there's an x. There's no constant right now, okay? So that's 3 terms. So I go GCF and table. Okay, so the GCF, do your variable check on the last term, and you got one. You got an x. Check for the negative in front. No. 3 and 27. If you look in the 3rd row, you will find 27. So it would be a GCF of 3. So I factor out a 3x. Okay. And I go up and divide by 3x. It's going to be 1x to the second plus 1x. Yeah, we got a little bit of a problem here. I'll figure it out. I'm going to change it to something. Okay. That certainly is a problem. Okay, because we're going to end up something we can't factor. Shoot. Change that to a 60. Okay. It's still 3x. Then minus 20. Okay, now we're talking. So A, B, C. 1 times negative 20 is negative 20. So it's a positive multiplied by a negative. And then 1 and 20. And we have to add to positive 1. Okay. 20 divided by 2 is 10. No. 3 is a decimal. 20 divided by 4 is 5. Okay, so you add those, and then positive 5, negative 4. So I'm going to map out my parentheses, okay, and then minus 4 plus 5. Okay, 1x to the second is your A. So if it's a 1, you don't really need to put 1 and 1. You can if you want, but you can ditch it. X, the power has to be broken up, x times x. X minus 4x plus 5, those cannot be reduced. I don't believe any of them is a difference of perfect squares. We know the plus isn't. The minus might be there, but the x doesn't have a power, so. Now I've rewritten that expression in factored form. Now, all the x's are just to the first power. If there's not a power on the x's, it's a first power. So they're all one solution. So 3x could equal 0, so I divide by 3, I get 0. x plus 5 could equal 0. We subtract 5, and x equals negative 5. And the other answer, x minus 4 equals 0, so if I add 4, I get 4. Okay, number 7, x to the power of 4 minus 12x to the power of 2 minus 64 equals 0. So this one would have 4 roots. It's not 4 terms, it's 4 answers. See, because on the terms we have x to the 4th, x to the 2nd, and the constant. That's 3 terms. So go to the reliable. Greatest common factor, then the trinomial t-chart. No x, no negative, and it's just 1, so we're not going to put a factor there. So the ABC's here, so 1 times negative 64 is negative 64. So we know that that's a positive multiplied by a negative, and we're trying to add to negative 12. 1 and 64, nope. Divide by 2, you get 32. Nope. 3 is a decimal. If you divide 64 by 4, you get 20. Or excuse me, 64 divided by 4 is 16. Okay, and that's negative 12. You know I was doing something wrong. So now a is 1x to the 4th. Okay, if it's a 1, you can put 1 in 1 or just drop it. So x to the 4th would be x to the 2nd times x to the 2nd plus 4 minus 16. Can't be reduced. Okay, so I check for more dots here. The plus can't be, even though if it's perfect squares, can't be done. This one here, you got x times x and 4 times 4. So x, 4, 4. So that's x plus 4 times x minus 4. Okay, kind of weird looking, but I get the 4 roots because this has 2 roots because it's to the 2nd power. These each have 1. Let's do the 2 first. So x to the 2nd power plus 4 equals 0. So I subtract a 4, and I get negative 4. Okay, so I got to poke the I out. Now, let's not leave the square root. If 4 is on the board, it's equal to 2, so x should be positive or negative 2i. Remember, i's come in pairs. Okay, then x plus 4 could equal 0, be negative 4. Then on x minus 4, it would be 4. We're going to come back to that problem here in a bit. Okay, x to the 3rd power minus 5x to the 2nd power minus 5x plus 20 equals 0. Okay, now there's 3 roots. Because we have x to the 3rd, do you have x second? Sure do. Do you have x? Sure do. Do you have a constant? Yes, you do. Okay, so that's 4 terms. So grouping. So parentheses plus the parentheses, then the line parentheses plus the line parentheses, then a little parentheses, big parentheses. So you have 1x to the 3rd power minus 5x to the 2nd power. Then I've got negative 4x plus 20. Okay, GCFs, you got x squared. You do not have a negative, and then the coefficients 1 and 5 would be 5. No x, you do have a negative. 4 and 20 would be a 4, so we factor those out. So I go divide by 1x squared here. I divide by negative 4 here. So it's going to be 1x minus 5, because these cancel. 3 minus 2 is 1x to the 1st power. That's going to be 1x minus 5. Okay, so we got the same thing, 1x minus 5. And then we combine the GCFs to make my other binomial. Okay, I'll check them over here. Okay, no plus. Okay, there's no plus, you can get rid of the 1s. That might be a minus, but that's obviously not different. That's a difference. It's just not perfect squares. This is a difference, and that's x times x and 2 times 2. So the plus is prime. Minus is also prime. So x minus 5 equals 0. So I get 5. X plus 2 equals 0. I get negative 2. And then x minus 2 could equal 0. You get positive 2. So those are your roots. I messed this problem up. This is supposed to be 7. Number 7. Refer to your solutions on problem number 7. Take the graph y equals x to the 4th minus 12x second minus 64. You do not have to draw this graph. Okay? It's just me showing it for effect. Leading coefficient would be positive 1, so it would go up this way. Okay? And then the exponent's even, so it also go up the other way. So what it does, kind of does that. Okay. Actually, that I didn't do a good job there, but you don't have to draw it anyway. Now the roots, okay, go back and look at number 7. The roots are your answers, 2i, negative 2i, negative 4, and 4. Again, when you set the function equal to 0, the answer for the independent variable are your roots. Now the x-intercepts are the roots, just don't include the i's, you just take those out, so it'd be negative 4 and positive 4. So that's wrong graph, it crosses it 4 times, it really only crosses it twice, okay, at negative 4 and positive 4. So yeah. Y-intercepts are easy. You just set your x equal to 0 and solve it. Well, if x is 0, then these are gone, and y equals negative 64. It's only going to cross the y-intercept once. Okay, if it crosses it twice, that's not legal because that's a non-function. It crosses the x more than once, but the y just once. Okay, find the quotient and the remainder. So we have x to the 3rd. You're not solving anything here. 1x to the 3rd minus 5x second minus 1x minus 5 divided by x plus 5. So this is how we divide algebra expressions. So we got a 1, a 5, a negative 1, and a negative 5. At least by a linear divisor. Linear means that x doesn't have a power. Now if x has a power, you have a problem, but it's really a worthless thing to really know. So we're just going to have our divisor linear. Linear means it's x to the 1st. Okay, so I get negative 5. 1 times negative 5 is negative 5. We add, we get 0. 0. Negative 1. Negative 1 times negative 5 is positive 5. Okay, so the remainder is 0. So that 1 used to be x to the 3rd. Well, now it's x second. Then it would be 0x to the x minus 1. The remainder is 0, so I don't have a remainder. Get rid of that 0x. If you have a 0, you get rid of it, and you have just 1x second minus 1, or x to the 2nd minus 1. Okay, on number 11, 2x cubed minus 7x squared minus 7x plus 13 divided by x minus 4. You're not solving this. Don't set it equal to 0 and solve. So you have 2, negative 7, and 13. So a nice linear factor for me to solve. So plus 4, plus 4. So 4 would be the divisor. 2 times 4 is 8. Negative 7 plus 8 is 1. 1 times 4 is 4. Negative 3 plus 4, 7 plus 4 is negative 3. Negative 3 times 4 is negative 12, and we get a remainder. Oh well, okay. I don't have to solve it anyway. So it's 2, it goes from x third to x to the 2nd. Plus 1x minus 3 plus our remainder of 1 over our divisor expression, x minus 4. It's not 1/4, it's over the whole expression. Okay, next one. This direction's use the rational roots theorem to find the solutions of the equation. So rational roots theorem is RRT, and then you find roots by synthetic division. So there are 3 roots. You find the last 2 by factoring, if possible, but you at least try it. The first one is found by the roots theorem. Okay. So my possible roots, well, we're going to have a 10 on top. Doesn't matter that it's negative 10. And the leading coefficient 1 on the bottom. So factors of 10, we got 1 and 10, 2 and 5. 3 is not a factor, neither is 4. And then you're just a 5, which you already have, and then 1 is 1. Divide all by 1, it's just 1 plus or minus 10, positive or negative 2, positive or negative 5. Okay, now start putting those in. That's going to find our first root. So 1 parentheses 1 to the third, plus 2 parentheses 1 to the second, minus 5 parentheses 1, minus 10. Didn't work. 2 is a possibility. 2 doesn't work. We're going 5, because 3 and 4 would be a waste of time. Okay, now let's go to 5. Okay, doesn't work, going in the wrong direction. I would just switch the single digits to negative. So 1, negative 1 to the third, plus 2, negative 1 squared, minus 5, negative 1, minus 10. Okay, negative 1 isn't it? Now try negative 2. This one's taking a little bit of time. Got it. Okay, negative 2. Now, you're going to get it down to an x to the second. So we have to divide by negative 2. So you got 1, 2, negative 5, negative 10. Drop your 1. 1 times negative 2 is negative 2. That's going to take me to 0. 0 times negative 2 is a 0. And negative 5. Negative 5 times negative 2 is 10. So remainder 0. Now we have 1x to the second now, plus 0x minus 5 equals 0. Now, you can do the GCFT, and you'd eventually end up using a QF, the quadratic formula, because your T-chart doesn't work. And you'd get the right answer, okay? You would. But you see, if I have 0x, we can get rid of that. So then I have just an x to the second with a constant, okay? There's no x. Well, in that case, I can just apply linear properties. So you can add 5, 1x second would equal 5, and then apply the square root, okay? Now the square root of 5, I don't need to poke the I out. It's positive. The square root of 5 isn't a perfect square, and it really doesn't simplify, so it's going to be square root of 5, and then square root of 5, negative. Okay. Now, if you use if you do GCF and T-table and then quadratic formula, you would get the same answers. You would. They would just be in decimal form. So that would be your first answer, and then you'd get a negative of the same thing. Okay, so do you on that. Okay, most of them the table works. Okay, simplify the expression. We have 3x to the second power, y to the third in a parentheses with a second power outside, times x to the second. Okay, now we simplify. We're not solving it for x. Okay. It's all multiplication. All these are just multiplication division. So you simplify it using your exponent properties. So we have a base of 3, a base of x, a base of y, and a second base of x means I'll just add to the first base of x. Okay, 1 times 2 is 2. Then on x we got a 2, but 2 times 2 is 4 there. Then I go find the other x, and it's to the second. So it ends up being a 4 plus 2, which is 6. Then y, 3 times 2 is 6. Okay, so if I look at all these exponents, they're all positive. Okay, so they all stay in the same position. This is the only one that can be simplified. It's 9. So it'd be 9 times x to the 6 times y to the 6, and then you can't multiply anything. Bottom's empty, that's okay. If the top's empty, you got to put a 1, but if the bottom's empty, yeah. Okay, number 14, 4x to the negative third power, y to the fifth power, that's all in parentheses, then you have a second power outside. So, again, all multiplication. So I go 4 times x times y. Okay, so I distribute 1 to 2, not to 5. The 2 is the outside, so 2, negative 3 times 2 is negative 6. 5 times 2 is 10. Okay. Okay, this one needs to switch positions. These two stay in their position. Switch him, x would be positive 6. So 4 to the second is 16, y to the 10th, and x to the 6th. Can't multiply anything there either. Okay, number 15. Now, on top we have division. That's okay. So 4 times a times b to the 6th times c to the 3rd. Then a to the 5th times b times c. So I just look at the top, we got 4 times a times b times c. On bottom you got a, b, and c. Okay, 4's to the 1, we don't, a's to the 1, b's to the 6, c's to the 3rd, no distributing. Then a to the 5th, b to the 1, and c to the 3rd. Now when you have things in the denominator, you want to see if you can cancel. It's all about simplifying. You have a on top, so you get rid of the smaller a and subtract that power from the other side. It was a 1, so it's 5 minus 1. If it was a negative 1, it'd be 5 minus negative 1. So that's a to the 4th. Okay. Minus 1, 6 minus 1 is 5, and then the c's are to equal powers, so the c's are eliminated. So 4 to the 1st, b to the 5th, a to the 4th. All positives, all maintain their same position. 4 to the 1st is 4, b to the 5th, a to the 4th. Okay, and we're going to skip the next two story problems and take a look at the last one. Profit P in millions of dollars for a t-shirt manufacturer can be modeled by P equals negative 1x cubed plus 4x squared plus x. That's a negative on the 1. If you don't get that as a negative, the whole problem's done. X is a number of shirts produced in millions. Currently, the company produces 4 million t-shirts and make a profit of $4 million. What lesser number of t-shirts could the company produce and make the same profit? So they give me the equation I'm going to be working with. And when they give you that equation, you have to know what the variables mean. So P is your profit, that's dollars, okay? X is whatever they're producing, which in this instance is t-shirts. Okay, so they tell me that 4 million t-shirts gives me a $4 million profit. So we're going to put 4 in for each one of those. So 4 for P, and then 4 goes in for each of my X's. This is me verifying that what they told me is true. Okay, put a 1 in front of that X, you'll need it later. Okay, so negative 1, 4 to the 3rd, plus 4, 4 to the 2nd, plus 1, and 4. Yep, it works. Now I want to keep us at the same profit of 4 million, but I want to find other X's that can give me 4. In other words, we're finding the roots. So there's 3 roots, and we already know one of them, okay? What did I just have in for x a moment ago that gave me 4? I had 4. Okay. So, need to move that over because you have x to the third and x second. When you have x to different powers, when the variable you're solving for is to different powers, okay, you have to move everything to one side and then decide the technique to do. Now, that's true. There are 4 terms, okay, but I don't want to waste time grouping, okay, even though I think grouping actually does work on this problem. But why would I do that when I already have my one answer, okay, because I know that I can use 4 there. -1, 4, 1, -4. Now be careful here. -1 times 4 is -4. Yes, that's 0. You keep going. 0 times 4 is 0. Then 1 times 4 is 4. Okay, we got a remainder of 0. Okay. Now, that equation I have now is -1x squared plus 0x plus 1 equals 0. Now, you can do GCFT and all that with your 0, okay? Be okay. But, if I have 0x, I can just take that out and apply linear properties. I don't need to do the GCFT when that goes away. Now, if you want to do the GCFT, that's fine. You would eventually stumble into the right answers. So it's 1. Apply the square root. You don't need to poke the eye out. Square root of 1 is 1. Okay, positive or negative, both of them. 1, -1. So the negative is deleted, and then my t-shirts would be in millions. T-shirts. Okay. There you have it. -1 is an answer to the equation. It's not an answer to the whole story problem.